Hello everyone, let's solve Leetcode 142 linked list cycle 2. Given the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. There is a cycle in linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pause is used to denote the index of the node that the tail's next pointer is connected to it. So it is -1 if there is no cycle. Note that pause is not passed as a parameter. Do not modify the linked list. So let's take the first example, right? So as you can see, we have a linked list, and the tail of the linked list is connected to the node at index one, right? It's connected to, as you can see, pose is one, right? So the tail of this linked list, it means the tail of the linked list, this is connected to the node at index one, right? So how do we solve this problem? How do we know the start of where the loop starts, the start of the loop? How do we know that, right? So to solve this problem, we are going to use Floyd's cycle finding algorithm. So the Floyd's cycle finding algorithm says, let's say we start, let's say this is the head, let's say we have the head, right? Let's say this is the head of a linked list, right? So the distance between, let's say, as you can see, the loop, the loop starts as this position, right? So the loop starts as this position. So that, let's call it the distance from the head of the linked list to this, where let's call it this. This point is going to be where the loop begins, right? The loop begins as this position, and the distance, let's call it, this is gonna be x, right? And the distance from the loop, where the loop starts, and from where the two pointers, the slow and the fast pointer, that means we are going to use two pointers, the slow and the fast pointer. The slow moves one step at a time, and the fast pointer moves two steps at a time. And when the meeting pointer, just the slow pointer catches the faster pointer catches the slower pointer, right? So if there is a cycle, the faster pointer it must, or it's gonna catch the slower pointer, right? But if it is a line, if there is no cycle in linked list, there is no way that the faster pointer catches the slower pointer, right? So let's call this distance the from the loop starts from to the meeting point. Let's call it this m, right? Let's call the first one h, where it is the head of the linked list, and let's call it just l, right, where the loop begins. So as you can see, we have two distance, right, x and y, and let's call this the length of the circle. Let's call it c, right? C is going to be the number of nodes in a circle. So as you can see, how many nodes do we have in a circle? We have three nodes, right? This node and this node and this node, right? They are in a circle. So the C is gonna be three, right? We have three nodes in a circle. So the length of the circle, right? So Floyd, so it says like, so the distance the slow pointer moves is gonna be just the distance of the slow pointer. Let's say the distance is gonna be distance of the slow pointer moves is just the sum of x and y, and let's say the other one is just, let's say, slow times this the length of the circle, right? How many times the how many times the slow pointer travels, I mean circles, how many times it's just moves in a circle. So it's gonna be the distance where this at a certain time, the distance where the distance the slow pointer moves, and the distance that the faster pointer moves at a certain time is gonna be distance of the faster is gonna be, the time has to be the same, and distance of faster is gonna be just the sum of x and y, and plus, let's call we have how many times it's moved in a circle. Let's call it f times c, right? So this is going to be the distance. So if the faster pointers travels travels two steps at a time, the distance it travels should be two times as much as the distance the slow pointer moves, right? So distance of the fast is gonna be just two times the distance of two times the distance ds, right? It's gonna be distance of s. So this means we're gonna have like, so we can just substitute the what the variables, right? They say x plus x plus y, this and times f times c. They say we have f times c. F times c is gonna be two times, so two times x is gonna be two times x. Since the distance traveled by, we are going to multiply. I mean, we have to take this one, right, and substitute in place of this. So, and it's plus we're gonna have two times y, and we're gonna have s times c, right? SC, let's call it SC, right? Or let's add dot here. So this is the equation, right? So we can just take this side, and I mean, when we, for example, when we like terms, when we collect like terms, so the one x is going to be cancelled, and the one y is going to cancelled, and we're gonna have like, let's move this side of this to the right, to the left. Let's say f fc minus sc is going to be c is the length of the circle, right? Is gonna be x plus y, right? We're gonna have x and plus one y. This is going to be the case, right? So we can substitute let's say we can take c in common, right? We have c in common here. We can just take the difference between f and c, right? So the difference of f and s, let's say we have this, the difference between f and c is going to be x plus y, right? We're gonna have x, the sum of x and y. So that means we can just say the f and s are the number of times the faster. The f is just the number of times the faster pointer travels in a circle, and s is the number of times the slower pointer moves in a circle, traveled in a circle. So we can substitute this difference. Let's say we can substitute this difference by x k. All right, we can say like that means we can just say just k times c is gonna be like KC is just the sum of x and y, right? It's gonna be the sum of x and y. So this means if we want to know the distance or the number of nodes from the head of the linked list to where the loop starts, just x, it is x, right? So x means kc minus it's gonna be like so we have moved this equation to this way, this side. We have moved this equation to this side, and we can say like just x means the distance from the head to where the loop starts, right? Is gonna be like k minus c. Yes, k minus c minus y, right? So the this is going to be the length from the head to where the loop starts. That means, so if so kc is just the how many times kc is the distance that the faster pointer moves from the starting where they meet, right? So it's gonna be this one. Let me we have, let's say we have here x, and we have here y, and we're gonna have c here, right? That's length of the circle. So x, so we have found an equation, right? X is going to be the distance of x is x is going to be kc times y, right? So let's say, for example, for this one, the loop starts at this point, the head is gonna be here, and the meeting point is gonna be here. So if for example, the slow, if let's say we start from, to know where they meet, to know where the loop starts, we can just eh, from this equation we can just say that x is going to be like k times c and minus y, right? Why we have minus one? Because we have from this point, from the start of the loop, we are saying like we have already traveled, the faster pointer already traveled. This is, let's say this x is the distance, what this the distance the slower pointer traveled, and let's say this distance is just the faster pointer has to travel, right? For example, if we start from, if the faster pointer move start from this position where they initially meet, it means it has to, if we decrement y, it means like we have already traveled y distance from the start of the loop, right? That's why we decrement, and we have to travel k times c distance to 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 meet the slower pointer. So let's say we have, let's say we start from, the slow starts from this position. Let's say uh, starts from, I mean the faster pointer starts from where they meet. So when they travel one step at a time, one node at a time, for example, if moves one node at a time, is gonna be at this position, and the slower pointer moves at one node at a time, is gonna be at this position. So they meet, right? Once they meet, that means they, it means like we have found where the loop starts, right? From this equation, like the distance x travels means like it just x is where what the slower pointer moves from the head, right? And k times c is just the faster pointer travels, then the distance the faster pointer travels before they meet in the where the loop where the loop starts, right? So have this reason is just why we decrement is just we are saying like we have to travel y distance, right? Y of the nodes in a circle. So only we can the faster pointer only need to travel k times c distance. So let's take this. We have already shown this problem. Like uh, the start of the loop is gonna be this node. So the time complexity is going to be, the time complexity is just going to be of n, and the space is going to be of one for this case, right? So I hope you have you understand the point, right? First, you need to know where they meet, and for example, you start from, for example, for this example, let me show you. The slow fast was initially pointing the head. The slow moves one step, it's gonna be here, and the fast moves at this position, right? Two steps. And when the slow is gonna be at, when the slow is here, the fast moves two steps, right? One step, and it's gonna be the second step, right? It's gonna be at this position, right? The fast is gonna be at this position. So when the slow is gonna be at this position, the fast moves one and two steps, right? It's gonna be at this position. As you can see, this node is going to be where they meet, right? It's a meeting line. And but we don't know like where the two nodes, where the again where the loop starts, right? So if once we know the loop, the once we know where these two pointers meet, we can just say like we can move the faster pointer one step at a time, and we can restart the slower pointer to the head of the linked list, and we will move both of them in one time, one step at a time. So one node at a time, right? So the slow moves one step, it's gonna be at this position. The faster was initially here, it moves one step at a time, it's gonna be here. They are pointing to the same node. So we can say like if the two, these two pointers start meet again, we can say like this is the start of the loop, and we can return that node. So I'm going to go to the implementation. So I have said the time comes is gonna be off in, then the space is going to be of one, right? So let's have slow pointer. Initially it was at the head, and we're gonna have a fast pointer. It was at initially the head, right? So while the fast, and if it is not the last, if it has next, I mean if it is not the last node, so what we're going to do is just slow moves one step at a time. So it's gonna be slow, and the fast is moves to two nodes at a time, right? So we can say just this: if a slow is going to be fast, if they are the same, what we're going to do, just we have found the meeting line, right? We have found where they meet. So meeting line, I mean meeting node, let's say meeting node is found, right? So meeting once meeting node is found, we can just say we can move the slower point to the head, right? The slower again points to the head. We restarted to reset to the head of the linked list, and while a slow is different from let's say different from fast, we can just move the two pointers one step at a time. So slow is just slow dot next, and fast is going to be fast dot next, right? Moves one step at a time. Then once we have done this, we can return either of the pointers. We can just let's say return false. I mean return the the slow, right? Then if there is no cycle, we can just return none right here. So let's see if it works for the test case. Okay. So as you can see, it passed for the three test cases, and let's submit it. So it passed for all of the test cases. If you like this video, please subscribe. It's going to be a lot to me, right? Thank you very much.